Hello everyone, we are from Group 1. So our today discussion is about energy efficiency and electromagnetic force analysis on electric bicycles for daily mobility. For our members, there are Muhammad Axel Baskara, Hukma Akbar Rusta Pratama, Rasad Arya Muhammad, Majiatul Lail Mandasini, Kenis Solail Sarumpait, Denis Arfasya Sujandi, Nathanael Kristanto Budiantoro, Darren Adrian Permana, and Muhammad Davin Hussein. So, for the introduction, electric bicycles are a sustainable transportation technology that converts electrical energy stored in a battery into mechanical motion. Because this operation relies on the fundamental concept of electricity and electromagnetism, where electric currents generate magnetic fields that produce the forces required to rotate the wheels. In this study, we analyzed the energy efficiency and electromagnetic force of an electric bicycle using simplified physics model and quantitative calculation to evaluate its effectiveness. Axel?
Okay, thank you, Akbar, for explanation. Uh, all right. So, how do energy efficiency and electromagnetic force affect the performance of electric bicycle as a daily mobility solution? Well, in this study, we investigate the relationship between the electrical consumption, electromagnetic force generation, and bicycle performance to evaluate the effectiveness of electric bicycle for everyday transportation.
So for the physical model, the battery supplies electrical energy to the motor. Electric current flowing through the motor windings generates magnetic fields. The interaction between these magnetic fields produces electromagnetic forces that create torque, causing the wheel to rotate and propel the bicycle forward.
And now onto the variables and parameters. Now here we have an input parameter table, and we can first begin with the first quantity, which is the battery voltage with the symbol V. The description for this is the nominal voltage of the battery with a value of 36. And the second one, we have a battery capacity with a symbol of C with a battery capacity of 10. And the third one, we have the motor power with the symbol P. This is the rated power of the motor with the value of 250. And next we have the total mass, which is the bicycle plus the rider on it. The symbol for this will be a small m, and the value of it will be 85, and units going to be in kilograms. And the next one, we have two velocities. The first one being in kilometers per hour. This is the assumed constant speed, which is the value is 20. And the next one is in meters per second, which is going to be 5.56. Now, the selected specifications are representative of a typical commercially available electric bicycle and are suitable for evaluating energy storage and power consumption characteristics. And here are some of the equations and their purpose. The first one is the
Well,
elect. Ini is me, right, or someone else?
it's me. It's me.
All right.
Equations and their purpose. So next up we have the equations and their purpose. We have four main equations. The first one is electrical power, where power equals volt times current. This equation relates electrical power to voltage and current supplied by the battery. The second equation is the electric current, which is a modification of the first one, where the power is divided by the volt used to determine the current required by the motor during the operation. And the third one is battery energy, where the battery energy is volt times ampere hour. This equation estimates the total electrical energy stored in the battery. And the fourth one is electromagnetic driving force, where the power equals the force times speed. This relationship connects motor power with the driving force acting on the bicycle. And for the next step, we have the calculations and the results. For the current consumption, the results are 6.94 ampere. So the motor requires approximately 6.94 ampere of current under the assumed operating conditions. The second one is battery energy, where the battery energy used is 1.296 times 10 to the power of 6 joules. The battery stores approximately that much of electrical energy. And for the third one, it's electromagnetic driving force, where the force acquired is 44.96 newtons. And the fourth one is operating time, where it is 1.44 hours. And the fifth one is estimated travel distance, where the distance estimated it can go under ideal condition, it is 228.8 kilometers.
Okay. The next one is electric bicycle drive system diagram. Number one is battery stores electrical energy and supplies power to the electric bicycle system. Controller regulates power flow between the battery and motor based on rider input. And rear hub motor convert electrical energy into rotational motion that drive the real wheels. Throttle sends a signal to increase motor power and accelerate the bicycle. Display units provides real-time information such as speed, battery level, and riding mode. And then assumption and model limitation. The first one is flat road, no road gradient. The bicycle is assumed to travel a flat surface. Effect of road gradient are neglected. And number two is no wind effect. The wind effects and aerodynamics, these two bands are neglected. And the number third is constant speed. The bicycle is assumed to move at a constant speed. Number four is constant total mass. The total mass of the bicycle rider system is constant. And the last one is constant motor efficiency. The motor efficiency is assumed to remain constant during operation.
We've made several assumptions to simplify the analysis. We assume that the electric bicycle operates under ideal conditions and travels on the flat road, so the effects of a uphill and a downhill slopes are ignored. We also neglect wind and aerodynamic effects, meaning air resistance is not included in our calculations. In addition, the bicycle is assumed to move at a constant speed with a constant total mass, and the motor efficiency is considered unchanged throughout the operation. These assumptions help us focus on the relationship between the electrical energy consumed by the bicycle and the electromagnetic force produced by the motor. These three images below summarize the assumptions used in our model. The first image shows that the road gradient effects are not considered, so the road is assumed to be flat. The second image shows that the wind effects and the aerodynamics are ignored, meaning there is no additional force from the air resistance. Lastly, the third image indicates that battery degradation is not considered, so the battery performance is assumed to remain constant over time.
Based on the calculated operating time of 1.44 hours and a constant speed of 20 kilometers per hour, the electric bicycle can travel approximately 28.8 kilometers on a single charge. This demonstrates that electric bicycles are suitable for short to medium distance daily transportation while efficiently converting electrical energy into mechanical motion through electromagnetic interactions. As you can see on the diagram, the electric bicycle achieves 28.8 kilometers on a single charge under the ideal conditions being on a constant speed of 20 kilometers per hour, driving on a flat road, no wind resistance, and a total mass of the rider plus bicycle totaling to 85 kilograms.
So the conclusion is the study demonstrates that electric bicycles utilize electromagnetic principles to convert electrical energy stored in a battery into mechanical motion through an electric motor. Based on the analysis, 36-volt 10 ampere hour battery stores approximately 1296 times 10 to the power of 6 joule of energy and supplies a 250 watt motor. resulting in a current consumption of 6.94 ampere and an estimate driving force of 44.96 Newton. Under the assumed operating condition, the bicycle can operate for approximately 1.44 hours and achieve a travel range of 28.8 kilometers. These findings indicate that electric bicycles are an energy efficient, practical, and sustainable transportation solution for short to medium distance daily mobility. So, and last the reference that we got is first from Holiday D. Resnick and Walker J. 2018. And then the second one is Survey R.A. and Jewett G.W. 2014. And the third one is Cherry CR 2007. And the fourth one is Fishman E. and Cherry C on 2016. And the last one is Hanan M.A. Hokyu Mohammed and Ayub A on 2017.